All right, 4 different types of transformations we're going to talk about here. So there's where the period transforms. So that's where the graph has a horizontal stretch or shrink. So that changes the period of the graph, the length of the cycle. We can have an amplitude change where it stretches this direction and the amplitude gets smaller or bigger, right? We can also have, this is, I know over to the next page, I was trying to figure out a better way to organize this, but we also have where we can move the whole graph left or right. That's called a phase shift. That's like the h value we always used with functions in Math 1050, moving it left positive h and right negative h, that type of thing. It's going to follow those same rules. And then a vertical shift is pretty much the same thing we've always called it, is where our graph moves up or down. And so that's going to change the midline of the graph. Changes where the midline is, right? Okay, so let's look at these examples really fast together. Hoping this won't take too long. I didn't scale the graphs for us, so we've got to figure out what scale we want to use. I don't know why my tablet's not like responding to me. So I suppose I should put my mic on so I can be heard. And then I'll write from the board instead. My videos aren't just good when I stand over here, but I'll just deal with it. Okay, so if we say, I don't know, I think I would want this to be 0 and pi, maybe 2 pi here, or something like that. So have this at pi, negative pi, I mean, and negative 2 pi. And then I don't want it to be really short, so maybe we should say, how big should we make 1? Should we say that 1 is 3 or 1 is down to this? I think right here looks good to me. We're going to call that negative 1. You can scale your graph any way you want. Okay, I'm going to graph y equals sine x. So that's the one we just learned to do. So that's where we start at 0, we go up to 1, down to 0, go down to negative 1, go back up to 0. And that graph would be, I didn't line it up perfectly there, but anyway, so you've got two cycles in that particular picture, right? Okay, so that's our graph of sine x. What happens, do you think, if we divide x by 2? It's actually going to be the opposite of what you think is going to happen. You can experiment with the graphic calculator to see what happens. So this one right here is going to be a horizontal stretch. So our graph is going to stretch so that instead of having up and down in 2 pi, all we have is an up. Think about it this way. If I were to plug a 2 pi into my function, so instead of x, plug in 2 pi. What's 2 pi divided by 2? Pi. The sine of pi, I mean, it's also 0, but the sine of pi is right there. So we just plugged in 2 pi and got the same value for pi, which we've basically taken that from the stretch over. So do you see why dividing by 2 is actually stretching it? It's making it twice the size. Because you're taking that number that's twice the size and dividing it by 2 to get the numbers that you originally had. Okay, so then this would be a stretch over this stretch. So we would have one fundamental cycle, or one, yeah, just that one cycle, but this time it goes clear from negative 2 pi to positive 2 pi. What happened to our period? The period is no longer 2 pi. How far does it have to go to do the whole thing? From negative 2 pi to 2 pi, how long is that? It is 4 pi, right? So this would be a period, so this one has a period of 2 pi, but this one here would have a period of 4 pi. Okay, what happens if we multiply it by 2 instead? So that would mean that we're plugging in an x value and multiplying by 2. So instead of plugging in, maybe I should use like pi thirds. Let's just do like, just think of it as this point, we're multiplying it by 2. So we would get the value for when it's multiplied by 2. So it's going to take it and shrink it back. I don't know if that makes sense, but it's basically going to be doing something like this. You know, it's getting really messy at this point. This one's a shrink by half. Isn't it interesting how left and right things are always opposite of what you think they should be? So again, it's this horizontal, and it ends up being opposite. So what happens to our period this time? Pi. We get the whole cycle in the length of pi. Does that make sense? So see where those numbers are? They are inside the arguments. That's where our parentheses kind of become important around. I know we got lazy with those in section 1.5, where I was like, let's just write theta and not do the parentheses. So the parentheses will become more important as we manipulate things within that argument, like putting a 1/2 in here or a 2 in here or something. It changes that for you. Okay? So then this one is our amplitude. This is just the outside number. So again, if I kind of go with my same, maybe I should go from 4 so it's easier to make it half. So if I go with my fundamental cycle, maybe I'll just stick with my same colors. So here, I don't know if you can kind of see how I'm like eyeballing my 5 key points to sketch that graph, right? So that would be this graph that has an amplitude of 1. What happens when we put a half in front of our graph? Our x-intercepts stay the same place. As half of 0 is still 0. But our minimum and maximum are half. So instead of 1, it's 1/2. Instead of -1, it's -1/2. But they're at the same point, x, y. X values, they just have, the y values have changed because the number's out front instead of on the inside. So the other one here, the 2 sine theta, that would be twice as tall, right? I don't know if I have, I'm guessing the right size. I have the graph right there. So this would be an amplitude of 2, where this one would be an amplitude of 1/2. So it's just that front number. Now something to keep in mind that I didn't specifically put in these problems, and that's negatives. What if we put a negative in front of it? What's that going to do to the graph just like it did previously? What if we put a negative in front of our sine or cosine? What did that do to other graphs? What did it do when we put a negative in front of our x squared graph? It flipped it upside down. So it's going to do the same thing with sine or cosine, where the graph will flip upside down instead. So let's do a y equals negative sine x. We'll just do one that goes upside down. It starts getting really messy, which is why I like using colors to help you see that. So the negative is a reflection upside down. The thing to keep in mind, though, is that amplitude is a distance. So even if you put a negative in there, guess what the amplitude is? It's still positive 1. Amplitude is always a positive value. The amplitude does not tell us whether it's reflected. That is a whole different piece. That negative in front of it is a different element of our power transformation, and it is not part of the amplitude. Okay, next. So this time we're going to play with our cosine graphs instead, and just switching things up. So let's do our basic fundamental graph. I like to put in my key points, just really helps me to sketch this. So I'm going to have a maximum at 0, a maximum at 2 pi, a minimum at pi, and then I'll have intercepts in between, and then I can just kind of sketch my curve, the curve in between. So I don't know if you see how those key points up. Right? Okay, so that's, we're going to call that graph. So what is negative, subtracting pi fourths from that, what is that going to do? Well, I should have been more careful with the way I counted this so that I can make it more exactly pi fourths. And I always think after the fact that I should be nicer to myself. Okay, let's see, pi fourths is going to be, I'm just going to count 1, 2, you've already sketched yours, and now you're like, oh man, I want to do it like she's doing hers. Well, that's what I have mine to do. Okay, so one, negative one, but the minimums 1, 2, 3, 4, let's go there. Maximum here. Those in the middles. Why am I like around this? 1, 2, 3, 4, 5, 6, 7. That's why. Dang it. Oh, I had 8. I only had 7. So that would put that one here, not there. Okay. Sketch your graph however you want on the graph. Okay. So the negative pi fourths means this is going to move to the right pi fourths. This is where those key points are really important. Do you see my key points on my graph? I was kind of careful about where I put them, right? Guess what I'm going to do with all those key points? 1, 2, 3, 4, 5. I'm going to move them all right pi fourths. And right pi fourths is a fourth. It's actually an eighth of the whole graph, isn't it? Because isn't this pi? This is 2 pi. So that means that this would be pi halves. So this is pi fourths right here. And all of our points are going to move that much, which the way I re-sketched this, I don't know if you've changed your graphs and sketched them like mine, I don't care. But I sketched it so that 2 of my little grids are the pi points. It would have worked fine with 1. Carefully enough. So that point that's normally at 0, 1, I'm moving it to pi fourths 1. And the point that's normally at pi half 0, I'm moving that one over 1. And the point here, I'm moving it at that one over pi fourths. I'm moving this one over pi fourths. I'm moving this one over pi fourths. And it just keeps the same exact shape of our graph, but moves the whole thing to the right pi fourths. What is this one going to look like? Left pi halves. So again, let's take our 5 key points. We're going to go left pi halves instead. There, and that's going to go there. This one's going to go there. Go 1, 2, 3, 4 to here. This one, 1, 2, 3, 4 to here. There it is. I've got my 5 key points to sketch in my graph. Well, that's interesting. That's going through 0, 0, just like a sine graph. Only instead of going up like a sine graph, it's going down like a negative sine graph. I feel like there's some sort of analysis we could do here. Cosine of x plus pi halves being equal to negative sine of x. I might be getting too complicated. We'll save that. Okay. Our basic graph here again. I suppose I should try and keep it the same as the one I just had, just for simplicity purposes. Although it goes off the graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Then I have to make that one. Okay, so here, 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 here. High on that one. So right here, there's my fundamental cycle. Yes? Okay. So we have cosine of x minus 3 halves. What does that mean our graph's going to do? Yeah, so down 3 1/2, right? So this point's at 1, so that point's going to go down 1 1/2. So that would be there to there. And this point's going to go down 1 1/2 to there. I don't know why I changed colors. And this point's going to go down, I don't know where, 1, 2, 3, 4, 5, 6, about right there. And this point's going to go down 1, 2, 3, 4, 5, 6 to about there. I'll go there. And then for this one to green, I decided to switch the color on me. Ta-da! What happened to our midline? It also moved. Guess what? Our midline is now at y equals negative 3 halves instead of where it was. Right? Exactly. Yeah. Yeah. So the midline and that number after the number that's adding and subtracting, those are going to. want to be able to identify. I was going to do cosine x plus 2, but based on the amplitude I gave my picture, I don't think I have room. So we can change the number on it, or we could just skip it. We need to do we did the one moving down, do we need one moving up? Or we could just say it moves up. This would be up to, you can sketch it if you want. Okay, so this takes us to properties of sinusoids, which can be either sine or cosine, right? And there's these other numbers in there. So there's an A. What do you think A is? A is the amplitude, but remember it's always positive. Okay, which letter in our sinusoid pattern has to do with period? We've got them all mixed in now, so which one is the period? Or is there a number that's the period? Do you remember back to those problems? Those are the tricky ones. Because the one that had a half in it was actually stretched by 2, and it doubled the period. And the one that had a 2 in it shrunk by 1/2, and the period was pi. So I don't think I can actually see the period in the equation at all. Do you see the period in the equation anywhere? It is not there. Okay? So what it normally is 2 pi. But if you divide the x value by a number less than 1, it's going to make the period get bigger, right? So basically, the period is going to be 2 pi divided by this little number right here, omega. That's a Greek letter, omega. It looks like a W, but it's omega. So it's going to be 2 pi divided by omega. Because if you divide by a fraction, it's the same as multiplying by a bigger number, and your period is bigger. But if you divide by a big number, then it makes the period smaller, right? So like in the problem that has a 2 in it, it was like 2 pi divided by 2, the period was pi. It was half what it normally is. Okay, so omega is the number of cycles in 2 pi. That's another way of kind of thinking about it. Okay, amplitude is always positive, so if you wanted to, you could call it the absolute value of A. Phase shift. Which number in there is the phase shift? That's the left or right fancy name for a left or right shift. Which number has to do with the phase shift? It's a weird Greek letter, so you may not remember what it is. It's called phi. Okay? Here's the trick though. Phi is not the actual phase shift if omega is not 1. Omega is 1, then phi is the phase shift. But if omega is not 1, then the phase shift is actually going to be phi divided by omega. And it's going to go the opposite direction, right? So notice how those have negatives in there. That's to help us indicate it goes the opposite direction. So maybe make a note to yourself that goes the opposite direction of the sign, just like we're used to with H. Okay, vertical shift is the easy one. What's the vertical shift? B. So B goes up or down, right? And the midline would be Y equals B. We just talked about that in our last example. Okay. Obviously, we run out of time to go through the actual examples. All this has been is instruction with examples leading up to the actual textbook example. So I can do separate videos of those if you need them as you're starting to work on this, right? I also have a little card. I mean, I need to cut out more of them. But I have a little card that's properties of sinusoids that has that stuff you just wrote down.